Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello everyone. Welcome to another tutorial on simple linear regression. I would like to brief you about what is simple linear regression. In simple linear regression, we predict scores on one variable from the scores on a second variable. We have an input variable x and one output variable y. And we want to build linear relationship between these variables. Here, the input variable is called independent variable and the output variable is called dependent variable. We have a data set consisting of two columns, one as annual franchise fee and one as startup cost. Here, we want to predict the value of startup cost based on the annual franchise fee. So, my x variable will be annual franchise fee and my y would be startup cost. We would like to get a linear relationship between these two in order to predict my startup cost for my testing data set. Initially, I have imported the libraries we will be using. First is matplot library, which will be used for plotting all my graphs, and the second one is pandas for reading my data set. Here, I have imported my data set using readCSV function and initialized my x and y variables with my annual franchise fee and my startup cost respectively. Okay, let's visualize the data set we have. So here is the data set plotted where the x-axis is the annual franchise fee and the y-axis stands for startup cost. These red plots are nothing but our data plots, the x and y values. Now let us split the data set into training set and test set. We will be using a function called train-test-split, which will split our whole data set into a training set and test data set. We'll provide our test size as equal to 3/5, which means 3/5 of our whole data set will be used for testing purpose and 2/5 of the data set will be used for training our model. Linear regression consists of finding the best fitting straight line through the points. The best fitting line is called a regression line. The line for a multiple linear regression model can be written as y equal to b0 plus b1 into x. Here, b0 and b1 are the coefficients we must estimate from the training data. Now let us see how to fit a regressor line. First, we need to import the linear regression class. Then, we need to call the function linear regression, which will return an object of its own type. We need to call the fit function, giving our x train and y train as parameters, which will give us our regressor line. Once we have called our fit function, we will get our values b0 and b1. Once the coefficients are known, we can use this equation to estimate output values for y, given new input examples of x. The green diagonal line in figure is the regression line and consists of the predicted score on y for each possible value of x. We have got this line by calling our predict function and passing our x test to it. And the result is stored in y prediction. The vertical distance from the points to the regression line represents the error of prediction. So the error of prediction for this point will be this vertical distance from the regression line. The error of prediction for a point is the value of the point minus the value predicted. As you can see, this particular red point is very near to the regression line. Its error of prediction is very small. By contrast, this particular point is much higher than the regression line, and therefore its error of prediction is large. How do you get a regression line? The most commonly used criteria for the best fitting line is the line that minimizes the mean squared error of prediction. What I mean by that is the least will be the mean squared error of all these points. The best fitting line will be considered as that particular line. So we have a function called mean squared error function, which we will import from sklearn.metrics, and we will pass our testing data and our prediction data as parameters to it. It will calculate the squared error and will give you the output. Here is the output mean squared error, and these are the B0 and B1 values we have printed earlier. At the end, I have visualized our test set results and our training set results. This is our training set results, whereas this is my test set results. This is the line which we have got, the regressor line to all these points.